Okay, so it's time to introduce friction to these because we've done quite a few without any friction. It's time to bring in friction. The first example, number 6, is actually identical to a sample problem in your textbook. And I did that because the first practice problem you're going to do tonight refers back to that example. So I want to make sure you have the example. So the sample in the book, and example number 6 says, a roller coaster of mass 200 kilograms is moving 4 meters per second at point A, which is 15 meters above the ground. It goes down a slope to point B, which is 6 meters above the ground, and it does 3,400 joules of work by friction along its path. So that's the E loss that they're giving you, work done by friction. What is the speed of the cart at point B? So if we draw our picture here, so here is the first hill, and it goes down and then it comes back up, okay? So this is A up here, and in the question it's telling us that this is 15 meters. And this is point A. And then over here is point B. And it's saying that this is 6 meters. And it's saying that as it went along this path, it lost 3,400 joules of energy to work done by friction. Okay, and it tells us the cart's mass is 200 kilograms and that it's going up here at the top at A 4 meters per second. Okay, so that's here at this point. And it wants to know what is its speed at B. So what is its, we'll call this our final speed. Okay, and so we do 1/2 mv initial squared mgh initial plus 1/2 kx initial squared equals 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. All right, so initially here at the top it has a speed, this term stays. It has a height, mgh stays. It doesn't have a spring, it goes. At point B, it has a speed, that's what we're solving for. It has a height, 6 meters. Doesn't have a spring, and there is E loss. So this time we have a lot more terms, and we're looking for V final. So we're going to take all the other terms over. So it's going to be 1/2 mv initial squared plus mgh initial minus mgh final minus E lost is equal to 1/2 mvf squared. Okay, cannot cancel out the m's this time because there's no m in this E lost. So we're going to multiply everything by 2 and we're going to divide by m. So we'll get E final equals, multiplying this term by 2, it'll be mv initial squared. Multiply the mgh by 2, 2mgh initial minus 2mgh final minus 2 E lost. Okay, that's because we were getting rid of that 1/2. And then divide by m. And yes, you could divide by the 1/2 on the bottom. I just find that people tend to screw the math up when they do that. All right, and now we can fill our numbers in. There's no way I'm going to have enough room up here, but hey, I live dangerously, I guess. M was 200 kilograms. V initial, 4 meters per second squared plus 2 times 200 kilograms, 9.81 meters per second squared, and the initial height was 15 meters, minus 2 times 200 kilograms times 9.81 meters per second squared, final height 6 meters, minus 2 times E lost, 3,400 joules. And then this whole thing gets divided by 200 kilograms. Okay. All right, and when you do this, you get a VF squared of 158.58 meters squared per second squared. Take a square root. VF is 12.5929 meters per second. Okay? Now, today in the practice question, they're going to put another point over here and call it C. And they're going to ask you, I forget what it is, but it's referring to this same diagram, okay? So that's example number 6. Example number 7 is another one with E lost, and it's a person sliding down a slide. So it says a 60 kilogram person slides down a 12 meter high slide. So this is 12 meters. Here's my person, 60 kilograms. Starting from rest, so up here VI is 0. When the person reaches the bottom, they're traveling, so VF, 11 meters per second. If the slide is angled at 30 degrees, what is the force of friction acting on the person as he goes down the slide? So we're looking for friction. The H final down here will be 0. So the first step is to find E lost. Okay, so if we use our energy equation, 1/2 mv initial squared, mg h initial, 1/2 kx initial squared, 1/2 mv final squared, mgh final, 1/2 kx final squared plus E lost. So at the top of the slide, the kid's at rest, goes to 0, but has a height. That's what this 12 is your HI. No spring, unless you want to back the kid up into a spring. But at the bottom, has a speed, no height, no spring, E lost. So we have mgh initial equals 1/2 mv final squared plus E lost. And this time it's the E lost we don't know. So take your subtract your 1/2 mvf squared, and you will get E lost to equal 60 kilograms times 9.81 meters per second squared times 12 meters minus 1/2 60 kilograms, and at the bottom the kid was going 11 meters per second squared. And so when you do this, you get an E lost to be 3,433.2 joules. Okay? But that is not the final answer. The question wanted to know what is the force of friction. So remember, E lost is equal to the work done by friction, and we know that is equal to F delta D cos theta. Okay? And so we're looking for friction. So you're going to take the E lost that you just found, and you're going to divide it by delta D cos theta. So the E lost we just found was 3,433.2 joules. The delta D is the length of the slide. So the angle is 30 degrees and the height is 12. We could use sine of 30 is equal to 12 meters over the length. So the length will equal 12 meters divided by the sine of 30, or 24 meters. So then we go down here and we put 24 meters in, and our angle, the kid's going down the slide, this is the delta D, friction is acting up the slide, the angle between them should be 180. And that's going to give you a negative when you do this math. So you get friction to equal 143.05 newtons negative, where the negative means opposite.